Hey guys, so in this video we're going to learn about the inverse trigonometric functions. And to do that we're going to try and solve the following equations. The first equation that we have is cosine y is equal to 3 over 4, and we have to solve for all the values of y between 0 and 2 pi radians. Here y is the angle and the cosine of that angle is 0.75, and we want to know what are all the values of y or all the values of that angle between 0 and 2 pi radians that give us this value for the cosine of y. So here we can say that y is equal to the cosine inverse of 3 over 4. So this is the inverse cosine function. Now the inverse cosine function will always return a value for the angle between 0 and pi radians, or between 0 degrees and 180 degrees. Here of course we want to determine all the possible values of y in terms of radians. So if we set our calculators to radian mode and we take the cosine inverse of 3 over 4, we get y is equal to 0.722 radians. Now if you look at that angle on the unit circle, okay, we know that 0.722 radians is between 0 and pi over 2 radians, so it'll be in the first quadrant over here. So that is 0.722 radians. So of course we can say that the cosine of this angle, cosine of 0.722, is equal to 3 over 4. Now we know that the cosine of the angle is simply the x-coordinate of the point on the unit circle. Now the question is there any other angle in the range 0 to 2 pi radians where we get the same x-coordinate as this point on the unit circle? And the answer is yes. If we mirrored this across the x-axis, right, we know that this point would have the same x-coordinate as this point. And now what is this angle over here? Well, this angle is simply 0.722 radians going in the clockwise direction. So that will be negative 0.722 radians. However, we know that y ranges from 0 radians to 2 pi radians. Well, if we took this angle here, if we took this angle right here, right, this would be between 0 to 2 pi radians. And the cosine for this angle, the x-coordinate, would be the same as it was for the angle 0.722 radians. So what is this angle over here? Well, this is simply 2 pi minus 0.722 radians. The entire revolution is 2 pi radians, but we're subtracting 0.722 radians. So then we can say that the other angle in this range, 0 to 2 pi radians, for which the cosine of that angle is equal to 3 over 4, is 2 pi minus 0.722 radians. Now let's solve the next question. Next question that we have is we want to solve for all the values of y for which the sine of y is equal to negative 2 over 3. And here y ranges from negative pi radians to pi radians. In other words, we want to find all the possible values for the angle y for which the sine of y is equal to negative 2 over 3, where y ranges from negative pi radians to pi radians. Now over here again we can say that y is equal to the sine inverse of negative 2 over 3. So this is the inverse sine function. And the inverse sine function will always return a value between negative pi over 2 radians to pi over 2 radians for the angle, or between negative 90 degrees to 90 degrees if we're using degrees over here. So if we take the sine inverse of negative 2 over 3, making sure that our calculators are set in radian mode, we get y is equal to negative 0.730 radians. Now if you look at the unit circle over here, the angle negative 0.73 radians looks like this. So here we have the angle negative 0.73 radians. And we know that the sine of this angle is the y-coordinate, of the point on the unit circle. So the question is, are there any other points on the unit circle for an angle ranging from negative pi to pi radians for which the y-coordinate is the same? Well, here, since we're also looking at negative angles, we can divide this interval from negative pi to 0 and from 0 to pi. Now, if you look at negative pi to 0, we have one angle here, that's negative 0.73 radians. We can also see that if we reflect this point across the y-axis, we get the same y-coordinate for the point on the unit circle. And this angle here is also 0.73 radians. And if we start from the positive x-axis, since we're looking at negative angles, if we start from the positive x-axis and go in the clockwise direction, right, this angle here gives us the same y-coordinate as negative 0.73 radians. So what is this angle here? Well, this angle is pi, that's 180 degrees, pi radians minus 0.73 radians. But it's the negative of that angle, so it'll be negative pi negative pi minus 0.73 radians. So therefore, the values of y are equal to negative 0.730 radians and 0.73 minus pi radians. So we can say here that the sine of negative 0.73 would be negative 2 over 3. That would be the y coordinate of this point on the unit circle. Similarly, the sine of 0.73 minus pi would also be negative 2 over 3. Again, that would be the y coordinate of this point on the unit circle. So we found the values of y for which sine of y is equal to negative 2 over 3 between negative pi and 0 radians. Now let's look at from 0 to pi radians. Well, from 0 to pi radians, we know that the sine of any angle from 0 to pi radians, we're going in the counterclockwise direction now, the sine of any angle here would be positive. So we know that these are the only two values of y between negative pi and pi radians for which the sine of y is equal to negative 2 over 3. The next equation that we have over here is that the tan of 2y is equal to the square root of 5. We want to solve for the angle y between negative 90 degrees and 90 degrees for which the tan of 2y is equal to the square root of 5. So here we can say that 2y is equal to tan inverse of the square root of 5. Now this is the inverse tan function. And the inverse tan function will always return a value for the angle between negative pi over 2 radians and pi over 2 radians, between negative 90 degrees and 90 degrees over here. So if we take the tan inverse of the square root of 5, ensuring that our calculator is set to degrees, we get 2y is equal to 65.9 degrees. Now if you look at this angle on the unit circle, the angle 65.9 degrees looks like this. We're going to start from the positive x-axis and go in the counterclockwise direction. So here we have an angle of 65.9 degrees. And let's say that this point on the unit circle has coordinates x1, y1. We know that the tan of any angle is the ratio of the y and the x coordinates. So the tan of 65.9 is y1 over x1. Now over here we want to solve for y, but we're taking the tan of 2y. So we shouldn't divide by 2 directly because we know that there can be multiple angles, there can be multiple values of y for which the tan of 2y is equal to the square root of 5. The first thing we want to do is they've told us that y ranges from negative 90 degrees to 90 degrees. So we can say over here that 2y ranges from negative 180 degrees to 180 degrees. All I've done over here is I've multiplied everything over here by 2. So now, between negative 180 degrees and 180 degrees, one of the values that we get for 2y is 65.9 degrees. Is there any other angle in this range of a negative 180 degrees to 180 degrees for which the tan of which is equal to the square root of 5? Now again, we know that the tan of this angle is the ratio of the y and the x coordinate. So again, this range from negative 180 degrees to 180 degrees can be divided into two parts. You can go from negative 180 to 0 or from 0 to 180. So if we just consider the positive angle for now, that is the range from 0 to 180 degrees, is there any other angle here from 0 to 180 degrees for which the ratio of the y and the x coordinate is equal to the square root of 5? Well, the answer is no, because any angle here, the tan of that angle will be negative. The tan of any angle in the second quadrant will be negative. So there's no angle between 0 and 180 degrees. But we know that the tan of any angle is positive in the third quadrant. So between negative 180 degrees to 0, so now we're going clockwise, between negative 180 degrees to 0, we can see here, for example, that the tan of this angle, here, will be the same as the tan of this angle, 65.9. So for example, if we take this point on the unit circle, let's say it has coordinates negative x1, negative y1. All I've done is I've reflected this point across the origin. We know that the ratio of the y and the x coordinate is simply negative y1 over negative x1. That's simply y1 over x1. Again, we know that the tan of theta is positive in the first quadrant and in the third quadrant, right? So we can say that the tan of this angle here is the same as the tan of 65.9. Now what is this angle here? Well, we know that this is 65.9 degrees. And we know that this entire angle is 180 degrees. So this angle is 180 minus 65.9, right? That's the magnitude of this angle. But we're going to take negative 180 minus 65.9 since we're going in the clockwise direction. So we know that this angle is negative. So we can say that 2y is equal to 65.9 degrees and negative 114.1 degrees. So we can say that between negative 180 degrees and 180 degrees, these are the two angles for which the tan of which is equal to the square root of 5. So the tan of 65.9 is equal to the square root of 5, and the tan of negative 114.1 is also equal to the square root of 5. Again, make sure that we set our calculators to degree mode. So now we can say that y, or the possible values of y that we have over here, is 65.9 divided by 2. Since 2y is equal to 65.9 degrees, y is simply 65.9 divided by 2. So that gives us 32.5 degrees. And negative 114.1 divided by 2. So that would be negative 57.0 degrees. And of course, we can see here that both of these values of y satisfy the range of values of y given to us. So these are the only values of y in the range negative 90 degrees to 90 degrees for which the tan of 2y is equal to the square root of 5.